If you've ever crumbled a handful of rich dark soil between your fingers and felt that earthy smell rise up, you were holding more than just dirt. You were holding carbon, life's currency. And here's the part that's shaking up the scientific world. Soils store far more carbon than we previously understood. It's really a wake-up call for every gardener. Recent global research shows that soil carbon stocks are significantly larger than earlier estimates suggested. In fact, soils may hold more carbon than the atmosphere and all plant life combined. That changes everything. It changes how we think about climate change. It changes how we think about farming. And most importantly for us here at the Soil Science Garden, it changes how we think about our own backyards. Today, I want to walk with you through what this means, not as a distant climate headline, but as something deeply practical and powerful for gardeners at every level. Because the truth is, you don't need to be a scientist with a lab coat to influence carbon storage. You just need soil and the willingness to care for it. Let's dig in. When most people think about carbon storage, they picture forests, towering trees pulling carbon dioxide from the atmosphere. And yes, forests are incredible carbon sinks. But beneath those forests, and beneath your vegetable beds, lies something even more impressive. Soil is the planet's quiet carbon giant. Soil organic carbon is the carbon stored in soil as part of organic matter, like decomposed leaves, roots, microbes, compost, manure, and, well, countless invisible life forms. For decades, scientists kinda underestimated how much carbon was tucked away underground, especially in those deeper soil layers. Why was it underestimated? Well, because measuring soil carbon isn't easy. It varies by depth, climate, soil type, land use, and honestly, management practices too. Earlier models often focused on topsoil, ignoring those deeper carbon pools. But with new technologies, improved sampling, and refined models, we've learned that subsoil layers, sometimes down to 1 meter or more, contain massive carbon reserves. This discovery reframes soil as not just a growing medium, but as one of Earth's most critical climate regulators. And here's the part that really hits home: gardeners and farmers directly influence whether that carbon stays stored or escapes into the atmosphere. Let's bring this down from global scale to garden scale. When your soil stores more carbon, it means it contains more organic matter. And when organic matter increases, well, everything in your garden improves. Carbon-rich soil holds water better. It drains better. It resists erosion. It supports beneficial microbes. It improves nutrient availability. It buffers pH swings. It makes plants more resilient to drought and heat. Think about that for a moment. The same carbon that helps regulate the planet's climate is the carbon that helps your tomatoes survive a heat wave. This isn't abstract science. It's practical soil management. When we talk about building soil carbon, we're talking about building garden performance. The reason scientists are paying attention is simple. If soils store more carbon than we realized, then protecting and rebuilding soil carbon becomes one of the most powerful climate solutions available. But there's a flip side. If soil is disturbed, degraded, compacted, over-tilled, or stripped of plant cover, that stored carbon can oxidize and escape as carbon dioxide. What took decades or centuries to store can be lost quickly. Agricultural expansion, deforestation, erosion, and intensive tillage have historically released vast amounts of soil carbon. As gardeners, we may not be operating on thousands of acres, but the principles are exactly the same. Every time we disturb soil unnecessarily, leave it bare, or neglect organic inputs, we chip away at carbon reserves. Every time we mulch, compost, cover crop, and reduce disturbance, we build them back up. That's power, real power. Let's talk briefly about why this discovery matters scientifically. Older soil carbon estimates relied heavily on surface sampling and limited datasets. Many soils, especially in tropical regions and deep subsoils, were undersampled. Additionally, changes in land use weren't always factored accurately into global models. Improved remote sensing, global soil databases, and deeper core sampling have painted a clearer picture. Scientists now recognize that deeper mineral-associated organic carbon, carbon bonded tightly to soil particles, can remain stable for long periods. This stable carbon pool was often overlooked. For gardeners, this reinforces something important. Long-term soil health practices build lasting carbon storage, not just surface fluff, but stable, persistent carbon that sticks around. So, carbon enters soil primarily through plants. Through photosynthesis, plants capture carbon dioxide from the atmosphere and, convert it into sugars. Those sugars, well, they feed the roots. Roots exude carbon compounds into the soil, feeding microbes. When roots die, when leaves fall, when compost is added, all of that, it becomes soil organic matter. Microorganisms break it down, transforming fresh organic material into more stable forms. Some carbon becomes humus. That's dark, stable organic matter that can persist for decades or even longer. Some carbon binds to clay particles and minerals, forming complexes that, resist decomposition. Healthy soil is basically a dynamic carbon bank. Plants deposit, microbes process, minerals protect. Your job as a gardener is to keep that system functioning. Now we get into the actionable part, because this is where you and I can make real impact. First, keep soil covered. Bare soil loses carbon. Mulch reduces temperature swings, prevents erosion, and slows oxidation. Organic mulches gradually decompose, feeding soil life and increasing carbon content. Leaves, straw, shredded bark compost. They're not just protective blankets, they're carbon inputs. Second, reduce excessive tilling. Tillage introduces oxygen rapidly into soil, accelerating decomposition and carbon loss. I'm not saying never loosen soil, but minimize disturbance. Transition towards shallow cultivation or no-till where possible. Third, grow more roots. Living roots are carbon pumps. Cover crops during off-seasons keep photosynthesis active. Even in small gardens, winter cover crops like clover, rye, or vetch can significantly boost soil carbon. Fourth, compost consistently. Compost isn't just fertilizer, it's stabilized carbon. Regular compost applications gradually raise soil organic matter levels. Fifth, diversify plants. Different root architectures deposit carbon at different depths. Deep-rooted plants contribute carbon deeper into the soil profile, helping build more stable reserves. These practices aren't trendy fads, they're carbon strategies. If carbon is the currency, microbes are the bankers. Soil microbes determine how much carbon stays and how much is released. Fungal networks, particularly mycorrhizal fungi, play a major role in carbon stabilization. They transport carbon deeper into soil and help form soil aggregates, those crumbly structures that protect organic matter. Healthy microbial communities increase carbon retention. How do you support them? Avoid overusing synthetic fertilizers that can disrupt microbial balance. Limit fungicide use unless absolutely necessary. Feed soil life with organic matter. Maintain plant diversity. When microbes thrive, carbon thrives. One of the biggest revelations in recent research is just how much carbon lies below the topsoil layer. In gardening, we often focus on the top 6 inches, but roots don't stop there, and neither does carbon storage. Deep-rooted crops like sunflowers, daikon radish, and certain perennials can actually help transport carbon deeper into the soil. That deep carbon is often more stable since it's less exposed to rapid decomposition. This is one reason perennial systems, like orchards, berry patches, and food forests, can become powerful carbon sinks over time. So, if you've been thinking about adding more perennials to your garden, well, this is just another reason to go for it. Carbon-rich soil holds more water. That's not theory. It's physics. Organic matter acts like a sponge. Increasing soil organic matter by even 1% dramatically increases water-holding capacity. In drought-prone areas, this can mean the difference between crop failure and survival. So when scientists say soil stores more carbon than we realized, what they're also saying is this: soil has more capacity to buffer climate extremes than we previously believed. That's empowering. While soils are powerful carbon sinks, they're fragile. Disturbance, erosion, compaction, overgrazing, and chemical imbalance can cause rapid carbon loss. Once lost, rebuilding takes time. That's why, soil protection matters just as much as soil building. You really want to avoid leaving soil exposed to heavy rain. Protect it from wind erosion too. And, prevent compaction by limiting foot traffic on wet soil. Rotating crops helps maintain biological diversity. Carbon security, folks, is soil security. It's easy to assume, honestly, that climate conversations belong to governments and corporations. But gardeners, we manage millions of acres collectively. Urban soils, suburban lawns, community gardens, homesteads, they all add up. When managed regeneratively, these spaces become decentralized carbon storage networks. And, unlike industrial systems, gardeners often have flexibility. We can experiment. We can adapt quickly. We can prioritize soil health over short-term yield. That's influence. Here's something important. Soil carbon builds gradually. You won't double organic matter in one season. It's a steady process, but consistency compounds. If you commit to mulching, composting, reducing disturbance, and planting cover crops year after year, your soil transforms. It becomes darker, more crumbly, more alive. And beneath that visible improvement is a quiet increase in carbon storage. At the Soil Science Garden, we focus on understanding soil deeply, not just as a growing medium, but as a living system. The revelation that soils store much more carbon than previously understood reinforces our mission. It tells us that soil health isn't a niche topic. It's actually central to food security, water management, climate stability, and plant resilience. And it tells us that gardeners are not small players in a big story. We are part of the solution. Every compost pile is climate action. Every mulch layer is carbon storage. Every cover crop is a photosynthetic carbon pump. I want you to look at your garden differently after today. Don't just see plants, see carbon flows, see roots transferring atmospheric carbon underground, see microbes locking it away. See your soil as a long-term carbon vault. Start small if you need to. Add compost this season. Try one cover crop bed. Reduce tillage in one section. Observe how your soil responds. Measure organic matter if you can. Track improvements. Treat soil carbon like a garden metric worth watching. Because it is. Soils store much more carbon than we previously understood. And that discovery isn't just scientific trivia, it's a call to action for gardeners everywhere. If this deep dive helped you see soil in a new way, make sure you subscribe to The Soil Science Garden and share this with fellow gardeners who care about building healthier soil. Together, we're not just growing plants, we're building living carbon banks beneath our feet. Let's keep digging smarter.